When we're operating for one-step equations with fractions or decimals, we still have the same basics of inverse operations. In this first problem, I can see that it's a subtraction. It's subtraction keeping my variable from being alone. So I know that since I see subtraction, I need addition. My next step would be to add 1/2 to both sides. I want to show that this cancels out. Minus 1/2 plus 1/2 cancels. I'm close to getting that variable alone, but I need to be really careful because here I don't have common denominators, and that's something I need to fix. When we're thinking about adding or subtracting in fractions, we need a common denominator. We need the least common multiple. In this case, 9 and 2, my common denominator is going to be 18. I need to rewrite these so that I have denominators of 18. To convert 5/2 to have a denominator of 18, or 5/9, excuse me, I'm multiplying by 2. So that's going to be 10/18. For 1/2, I would need to multiply both of those by 9, numerator and denominator. So that's 9/18. Final answer, 10 plus 9 is 19/18. I keep the denominator. I could keep that as my final answer. There's nothing wrong with an improper fraction, or if I wanted to, I could rewrite it as 1 and 1/18. Either way works. For this multiplication problem, I see a multiplication, so normally I would think that I need a division. But here we know that dividing by a fraction is the same as multiplying by the reciprocal. So that's where I think it's much easier to see a fractional coefficient, multiply both sides by the reciprocal. One little thing I do when I see a negative, I like to draw a circle. I'm attaching it to the numerator. It could go to the denominator. This is just a force of habit I'm in that helps me keep things straight. From there, if I want to multiply both sides by the reciprocal, that means I'm going to flip that fraction. 3 and 3 cancel, -2 and -2 cancel, and I've accomplished my goal on the left of isolating the variable. On the right, when I go to multiply by 3 over -2, one thing I might look out for is cross-canceling. I know that 12 and 3 are both divisible by 3, so I'm going to simplify. I'll make that a 4 and a 1. 8 and -2 are both divisible by 2, so I'm going to make that 4. Divided by 2, make it -1. And now I'm going to multiply straight across my numerator. 4 times 1 is 4. 4 times -1 is -4. And then I'll simplify. 4 divided by -4 is actually -1. If I had paused earlier, gone up to the first step and simplified, I might have realized that sooner, but either way, I think it's really important with fractions to look at how you can simplify each step of the way. And to check either of these final answers, I would substitute back into the original. So for example, on this second one, -2/3, if I think y is -1, I can sub it in and see if that equals 8/2. If nothing else, I know that a negative times a negative equals a positive, so I'm on the right track. If I simplify here, divide by 4 on each, I know I have the correct final answer.